Hello. Hello my dear students, how are you all? Welcome to one more amazing session from Infinity Lane. This is Suresh, Faculty of Chemistry. Today we are going to discuss the topic periodic properties, NEET most expected questions as a part 1. Tomorrow we are going to discuss about the part 2. How are you all doing? Nashi, how are you? Fine, right? So in the journey of NEET 2025 preparation, we completed NEET NCERT line by line, and we are in most expected questions 1000 question series. In this series we are going to discuss about each and every concept and NEET related questions based on this NCERT based NEET related questions, and 1000 questions daily 30-40 questions we are going to discuss. So next for 45 days you are going to discuss minimum of 1000 questions and maximum of 1500 questions. So get ready. So in this journey we started practical organic chemistry yesterday, and day before yesterday we had chemical bonding and molecular structure. Today we are in periodic properties. Hi Nashi, good afternoon. Wow, understand how? Please confirm you are able to hear me. Hi Maunika, hello. Yashashya Sharma, yes, good afternoon. So, how you enjoyed yesterday's class, Maunika? Yeah. So, before starting the session, I just want to say, worth of the day, crack your NEET examination. So, for that reason, we are all here. So, please attend the class on regular basis and take a pen and paper, solve the questions along with me. I am going to discuss the question as well as the concept related to the question, and we are discussing the proper answer as well. Right? Thank you, Yashashya Sharma. And for that, please like and share and comment and subscribe to Infinity Learn NEET YouTube channel. For that, I just want to say, is your test preparation, your Google Play Store में आपको ये Infinity Learn का ऐप है, उसमें आपको लाइव क्लासेस, मॉक टेस्ट, क्रिएट योर ओन टेस्ट एंड 24/7 डाउट रेजोल्यूशन सेशंस. राइट, गॉट इट? या हेमंत, हाउ आर यू? So without delay, I just want to give you some inputs related to periodic classification, then we start the questions. Right? First you want me to start the questions or little concept, a mapping? Sai Suresh Kumar, how are you? So option is yours, concept or question? A short concept or a question? Okay, let's see here. Total periodic classification. Keep this slide in your database so that it can be helpful to you. Take a snapshot. 3, 2, 1. So periodic classification, you have Newland's law of octaves, Dobereiner triads, and Mendeleev, and you have modern periodic table. Yeah, concept first. So in this Dobereiner triad, the principle of classification, it is a triad. 3 elements are taken. In these 3 elements, the atomic mass of first element and the last element average is going to be the middle element. So this is the actual model. It has a limitation, identified only 3 triads from the known elements during that time. Okay, later on, early attempts, Newland's law of octaves are given. So it model gives rise to Saregama kind of thing, and it is only applicable for the first few elements, not for every element, and valid up to calcium, and assumed only 56 elements are there in the periodic table, and 2 elements in the same slot, cobalt and nickel, are coming into this way. And you have principles of classification, and elements are arranged in the order of their atomic masses. This and this are comes under the order of atomic masses. So if you consider the Mendeleev periodic table, it is also in the modern, it is the basis of the modern periodic table, and elements are arranged in increasing order of atomic masses and found that groups and periods, and inert gases are placed without disturbing the existing order. That is itself is a drawback, and achievements gaps in the table attributed to the undiscovered elements. Ecaboron and ecasilicon comes in this way, and limitations, it is not able to accommodate isotopes in that way. Hydrogen is not given a proper place to that. And of course, total periodic table in one slide modern periodic table, and we are arranging the elements in increasing order of atomic number and electronic configuration. And we have groups and periods. Groups elements having the equal number of valence electrons according to the electron configuration, and elements having the equal number of valence electrons shells placed in the same period. And also principles used is atomic number as well as electronic configuration and valency, atomic size, metallic nature, non-metallic nature. Every property has been discussed according to the modern periodic table. Can you tell me who designed this modern periodic table? Chart box, use the chart box. And a few minutes only, I just want to take a good things, useful things to you. Yeah, thank you. Who has given modern periodic table? The periodic table that is printed in your textbook, and we are all using the periodic table. Who designed that? Can anybody knows it? Let me know in the chat box. Niels Bohr has given his periodic table. Yeah, can't remember. Niels Bohr beta. It was first Mendeleev periodic table is given. Mendeleev periodic table is modified by Moseley periodic table by replacing with atomic number. Later on it is electronic configuration by Niels Bohr, that is modern periodic table. Yashasya Sharma, fine. Now let's talk about the total periodic properties wherever you are going to get a question based on this only. Everybody take a snapshot. 3, 2, 1. Mil gaya? So how the atomic radius periodic properties increases or decreases across the period and down the group. एक simple slide में बना के रखा. So atomic radius decreases across the period, increases across the down the group. Similarly, ionization potential across the period increases, decreases down the group. Electron affinity across the period increases, down the group decreases. Maunika. And covalent character, metallic character across the period, non-metallic nature increases, down the group metallic nature increases. And the screening effect of basic character, all are related. All are related. Okay, taken a snapshot everybody. And some unified truth also. I just want to give you 50 unified truths on the periodic table, then we'll start the questions. Taken picture 3, 2, 1. Clear? Fine. That's good. Now let's talk about the element with the lowest electronegativity, cesium. Highest electronegativity, fluorine. Highest ionization potential element, helium. Lowest ionization potential, cesium. Lowest electron affinity, noble gases. Highest is going to be chlorine. A बहुत important चीज है. Fluorine is not. It is going to be chlorine. Mind it. It is going to be chlorine. Fine. And least electropositive element. ये इस चीज का interrelated है ना? And also low element with lowest melting point of the metal. It is going to be mercury. Element metal with lowest melting point. Highest melting point and boiling point metal. That is going to be tungsten. Symbol is W, wolfram. And lowest melting point, boiling point, non-metal, helium. Helium. Oh, electron affinity. I am going to finish this, then I am going to explain you that. Yashasya Sharma. At least thanks for asking, right? Agar, do you have any specific doubts like Yashasya Sharma is asking, please let me know. I am going to address this. This is not a radio telecasting session. It's an interactive session on YouTube platform from the Infinity Land. Okay, students, you can interact with me and I can interact with you. And also, this is absolutely free. And get advantage of this. Okay, उसमें फायदा उठाने की कोशिश करो. That's why I strongly recommend you attend the class on the regular basis and take the knowledge from us. And I swear definitely you will be doing good, awesome in your upcoming NEET examination. You are with me? A thumbs up and fire emoji in the chat box. Yeah, आगे बढ़ते हैं. Now, notorious element, hydrogen. Why you say notorious element? Because this is the element has no place. Somebody says it is present in the group 1, somebody says it is present in the group 17, it has no place. And lightest element is again hydrogen. And smallest atomic size hydrogen फिर भी. Maunika, thank you. Largest atomic size is cesium. Cesium is the largest atom in the entire periodic table. Largest ionic size iodide, I minus iodide, right? And smallest cation H plus में क्या रहेगा? सिर्फ न्यूक्लियस रहेगा, उसमें कुछ नहीं है, right? Most electropositive, most metallic cesium. And element with electronegativity next to the fluorine, oxygen. Electronegativity order जो है, fluorine is greater than, oxygen is greater than nitrogen, mind it. Okay, and total number of gaseous elements you can see in the periodic table. Hydrogen 11, total number 11. Hydrogen, nitrogen, oxygen, fluorine, chlorine, helium, neon, argon, krypton, xenon, radon. Total 11 elements are present, right? Next, 20. Altamash, hello. I said it is 50 na, so 20 किया फिलहाल. Now 21, the total number of liquid elements. So there are 6: gallium, bromine, cesium, mercury, francium, UUB. You know, gallium is the element. It is liquid in summer, okay, solid in winter. Even in the winter, you take the gallium and put it in the hand. Because of the warmness of the hand, it is going to melt, right? So that is the funny thing. Gallium is used in the high temperature thermometry. Gallium exists as Ga2, right? Now, total number of radioactive elements, oh chalte rehte hai, this is not that important, okay, because radioactive elements, any artificially discovered elements are going to be radioactive. Hemant, summer, liquid gallium, yeah. And after lead in the periodic table, all elements are going to be radioactive. Just keep the thing in your mind. Oh, really? And volatile D block elements. What is the meaning of volatile? When the metal is heated, it is going to be sublimated, evaporated. So, zinc, cadmium, mercury and UUB. Zinc, cadmium, mercury are volatile. Okay? And element containing no neutron. Hydrogen has no neutron. Deuterium has 1 neutron. Tritium has 2 neutron. Hydrogen का isotopes है. So कम से कम ये जानकारी करना पड़ता है ना. And most abundant element on the earth, oxygen. In the earth crust, right? Most abundant metal on the earth crust is aluminum. Most abundant element on the earth crust is aluminum. And element having maximum tendency of catenation, carbon. That's the reason why it forms chains and links. And non-metal having the highest melting point and boiling point, carbon. Diamond, allotrope has the highest melting point. Hardest naturally known material is diamond. है ना? And metal showing highest oxidation number, osmium and ruthenium shows +8 oxidation state. +8 oxidation state का ऊपर कोई एलिमेंट दिखते हैं नहीं. Okay, 2, 5, 0, 0, 0, 0. What is that, beta? What is that, Altamesh? What is that number signifies? Next, 31. Most electrovalent compound, cesium fluoride. Most electrovalent means it is most ionic Electrovalent bond means ionic bond, right? And the most stable carbonate, cesium carbonate. You know, most stable carbonates are alkali metal carbonates, group 1 carbonates, except lithium carbonate. You want to do sodium carbonate, you want to heat lithium carbonate. So lithium carbonate is going to be decomposed to gives rise Li2O and CO2. Whereas lithium, sodium carbonate do not. Alkali metal carbonates do not decompose. Yeah. Carbon compounds का number है. अरे the number you have given is the approximate number. Every day, just like a population, somebody discovers some new compound means it is going to be increasing its number. Alchemist. That is the speciality of the organic chemistry. Okay, anyways. Strongest basic oxide, cesium oxide, strongest base and alkali is cesium hydroxide, and best electricity conductor among metals, silver is the best conductor. Then why you are not using at home? Because silver is costly and it is more prone for oxidation. Okay, then you can use aluminum also, but copper we use because it is less prone for oxidation. Now, most poisonous element, plutonium. Okay, Madam Curie exposure to plutonium and polonium. Madam Curie का जो dead body है ना, it is wrapped in lead coffin because she exposed to radioactivity. During that time, she was not aware of the radioactivity, and her body is still radioactive, right? And liquid non-metals, bromium is the only liquid non-metal, right? Element kept in the water, phosphorus, white phosphorus rather I say, white phosphorus are stored under water. You want to take the white phosphorus, translucent substance, you take it out from the water, even in the room temperature it will catch fire. Its ignition temperature is at room temperature. Why it is ignites? Because of the P4 structure, high ring structure, ring strain is there, angle strain you can say, because of that reason. Okay, element kept in the kerosene, all 1A group element except lithium is kept in the kerosene. Why except lithium? You are learning chemistry with me, come on, why it is not showing? Lithium is not stored in kerosene. Radioactive element means the element when it is nucleus of that element continuously disintegrate into alpha, beta, gamma particles, and that phenomena is called as a radioactivity. Okay, Yashasha, I will come to your doubt. Okay? Next, yes, 52, 50 बोला ना आपको 52 दे रहे हैं, and after this slide questions now. Okay, come on, elements sublime on heating. Iodine, when you heat it is going to sublimate. Non-metal, noble metals, AuPt. Why? Because they don't react with oxygen. And amphoteric metal, beryllium, zinc. अरे ये चीज़ आपका काम आ जाएगा. Beryllium, zinc, aluminium, tin, lead, gallium. And metalloids, silicon, arsenic, tellurium, acetine, germanium and tin. And non-metals having a metallic luster, non-metals having a metallic luster, graphite and iodine. Graphite and iodine, pencil lead hai na, you just see it appear like a metal, but it is a non-metal, right beta? And heaviest naturally occurring element, uranium. Heaviest naturally occurring metal, uranium. Lithium is lighter in weight than kerosene. That's the reason why Hemant is given the correct answer. Everybody follow Hemant. Hemant, very good, because lithium has to be stored by wrapping in wax. Lithium is stored in wrapping in wax. Okay. And poorest conductor of electricity is diamond. Hardest naturally occurring element diamond. Lightest solid metal is lithium, and this is the lightest solid metal. 90% of the sun mass is hydrogen. More than that, approximately 90 is given, more than that. Amphoteric oxides are better, and this is very, very important. Everybody, beryllium oxide, aluminum oxide, zinc oxide, PbO, PbO2, SnO, SnO2, Sb2O3, As2O3, Cr2O3, these are all amphoteric oxide. Pb3O4, it is not. Okay. Neutral oxides of the non-metal, NO, CO, H2O and 2, only the neutral oxides. Okay. And CO is deadly poisonous, right? So you got a good information from this, right? Very good information, na? 52 facts. और एक 50 दे सकता हूँ. Take a snapshot, everybody. Children, you want to take it? Take a snapshot. Take 3, 2, 1. और एक this one. Take 3, 2, 1. I suggest all the students take a snapshot for this. That's why I am just out of the frame, but I am watching your charting and all. Maunika, next one. 21 to 30. Hey, now. Right. Altamesh, Maunika, Hemant, Yashasya Sharma, are you there? Next, this one. Very good. Okay, Yashasya Sharma, come on. And the last one. And the last one. Lovely, perfect. Come on. Done. So, we'll go into the questions now. The atom having the valence shell electron configuration 4s2 4p2 would be in which group and which period? As this is showing here fourth shell. This is the fourth shell, है ना, period 4. And S2 P4, S2 P1, S2 P2, S2 P3, S2 P4, S2 P6, P5, S2 P6. So it is present in group 13 and group 14 and group 15, group 16, group 17 and group 18 है ना. हमारा जो है ना group 14 होगा. So that group 14 means group 4A and period 4. Meticulously you have to look at this answer and you have to decode it, and your answer, Maunika, it is correct answer C. Wonderful, wonderful, wonderful. Yashasya Sharma, appreciated. Very good. Next, the electron configuration of transition metals exhibited by. When you look into the NCERT, I don't mind to keep your NCERT along with you and give the answer along with me. Right? Acha hoga, kar do. And when you see the NCERT textbook and transition metals N-1D 0 to 10, 1 to 10 and NS 0 to 2 hoga, right? So based on that you are going to say NS 1 to 2 and it is supposed to be N-1D 1 to 10. Okay, so that it is going to be answer A. So this is given according to the old textbook, it is given according to the new textbook. Anything it goes. Okay. So I would say, yeah, chalta. Next, which of the following electronic configuration are outermost shell characteristic of an alkali metal? Alkali metal has NS1 configuration. है क्या ना? Alkali metal has NS1 configuration. But NS1 यहाँ पे देखें, NS1 का पहले क्या क्या चीज होना? Noble gas होना. So that noble gas has 8 electrons in its outermost shell. So that your answer is going to be here. Don't look at this various types of electronic configuration. Answer C is going to be the answer for this question. Monica, understood? So students are continuously chatting with us and attending the classes, and the graph goes like this. It is the peak now. 334 students are there now. Come on, the chemistry of lithium is very similar to that of magnesium. Why? Because lithium, beryllium, boron, sodium, magnesium, aluminum. So they are going to, why not be? I'll tell you. Lithium is going to show the similarity in properties with magnesium. Beryllium is going to show similarity in properties with aluminum due to diagonal relationship. So the reason behind the diagonal relationship is for the similar polarizing power. Polarizing power is attributed to charge to size ratio. So charge to size nearly same, the ratio is same. That's the reason why we are going to give the answer D. Got it? So everybody says is a diagonal relationship. So diagonal relationship का reason, इसके पीछे reason क्या हो सकता है? Yes, option 4 is the correct answer. So I want you to be very aggressive when you give the answer. So let the answer be wrong, but you have to present yourself so that I understand what is your wrong and I am going to correct you. Right beta? Now previous one, ये electronic configuration होता है ना, d electrons कहाँ रहते हैं? And outermost electron configuration of the alkali metals में d orbital इस्तेमाल नहीं करता यशस्विनी, right? Got it बेटा? Now आगे बढ़ो. Configuration of bromine minus is 3d10 4s2 4p6 हमको पता है. The electronic configuration of Br2 plus would be identical with. It's a logical question. It's a logical question. Who is going to give the answer? So in the next class onwards, I just want to make a poll in the chat box itself. So हर question का poll आएगा. So you have to click the correct answer. Understand? Yeah. What is the answer for this question, बच्चों? Answer, waiting for your answer. Yeah, you want to say D? Okay, let's talk about fluorine, chlorine, bromine and iodine. Come back. That is going to be oxygen, sulfur, selenium, tellurium. Let us come back. Nitrogen, phosphorus, arsenic, antimony. So it is having NS2, NP5, P4, P3, है ना? He says Br minus has P6 configuration. P6 configuration. Got it? So Br2 plus का configuration क्या होगा? you just see Br प्लस का कॉन्फ़िगरेशन यही होता है, Br2 प्लस का कॉन्फ़िगरेशन ये आर्सेनिक का बराबर होता है P3. Understand? So my answer is going to be option B is the correct answer for this question. Got it? Clear, Maunika? So my answer is B and your answer is B. It is correlated. It is correlated, absolutely. Perfect. Now, one more 4D3 5s2 configuration belongs to 4D3 5s2 configuration belongs to. I want you to keep NCERT textbook along with you and you will understand. It is purely based on NCERT questions. NEET examination ask this type of questions. Who will give the answer? Jaldi. You want to say C, Yashashwini Sharma, 5B. So it is going to be C. Yes, exactly. Perfect. D1, D2, D3. Clear? 3B, 4B, 5B. So in the periodic table you can say you have 3B, you have 4B and you have 5B, you have 6B, it goes now, and you have 7B, you have 8B. This 8B comes 3 different groups, and you have 2B, 1B and you have 2B. This is the order, right? Why it is B against 5? So can't recall. Why actually this is 1A, this is 2A, this is 3A, okay, 4A, 5A, 6A, okay, 7A and 8A. This is also called a zero group. I'll tell you why this AB. Mendeleev is given periodic table, that is given by Moseley. After that it is metamorphosity for modern. This is the metamorphosis of the periodic table. When Mendeleev is given a periodic table, he named the group in A and B subgroups. And later on, Moseley removed all the elements from Mendeleev periodic table and he rearranged the elements according to atomic numbers. So that is modern Moseley periodic table. He found that A, B together are present. Moseley wanted to separate A category this side and B category this side. So it is coming a little bit lengthier version of the periodic table. So that periodic table, what you say, extended form or long form of the Moseley periodic table. Okay. So Bohr came, and when you take the atomic number, you can write the electronic configuration. So he arranged the electronic configuration version. So the same one for the Moseley modified into the modern periodic table. He wanted to say why this A category and B category, this much confusion. So he wanted to make it 1, 2, 3, 4, 5, 6, 7, 8 up to 18. So that is the Latin number is given. So there is no Roman number in this modern periodic table. Now you understand Yashashwini Sharma? Fine? Clear? Now let's look into the one more question. From the given set of species, point out the species with each set having the least atomic radius and the highest least atomic radius. least atomic radius. So these are the given species, and this is the version of the answer. Your answer lies here. These are the options. These are the options. It is going to be sodium plus nickel and beryllium. You just check it. You are going to, why do you give a graphical representation of the periodic table? Graphical representation of the periodic table is not required. Okay, that is not a table na, when you say a graph. Thank you Ashok Jadhav, thank you very much. And आगे बढ़ते थोड़ा सा कॉन्सेप्ट डिस्कस करने का वो मौका भी मिलेगा. So all the concepts I have to discuss. If some concepts are not, some questions are not covered, tomorrow we are going to discuss 45 questions, right? Yeah. So K plus argon, calcium 2 plus S2 minus contain. अरे उसमें कितना इलेक्ट्रॉन है? 19 इलेक्ट्रॉन था. एक इलेक्ट्रॉन निकालने के बाद इसका 18 इलेक्ट्रॉन बन गया. आर्गन का 18, कैल्शियम 20 इलेक्ट्रॉन था, अभी 18 मिल गया. सो सल्फर 62 इलेक्ट्रॉन गेन करने के बाद. सो दीज आर ऑल isoelectronic species. The species with the same number of electrons are called isoelectronic species. But atomic volume same कैसे हो सकते हैं? Isoelectronic species do not have the same atomic volume. Size Yashashwini, sorry, Yashasha Sharma, size is directly proportional to number of shells. That is a rule 1 and rule 2. Size, if number of cells are same, size is directly proportional to charge, negative charge, size inversely proportional to positive charge. You just keep this in your mind. Okay, based on that they should have the different volumes. My answer for this question is going to be C. Got it? Perfect. Nice. Okay बच्चों, आगे बढ़ते हैं. Next question. Which of the following is not isoelectronic species? Isoelectronic species मतलब same number of electrons. Same number of electrons. So you have to check the same number of electrons where it is present. So you can see N3 minus में आपका 10 इलेक्ट्रॉन है, S2 माइनस में आपका 18 इलेक्ट्रॉन है, आपका 18 इलेक्ट्रॉन है. It is not isoelectronic. They are not isoelectronic. My answer is going to be D. So you kept quiet. You should give the answer, no? Make it fast. Make it fast. Expecting an answer. आगे और एक क्वेश्चन है. Now IP1, IP2, IP3, IP4, IP5 of the element are 7.1, 14.3, 34.1, 46.8, 162.2 electron volts respectively. The element likely to be. IP stands here, ionization potential. So I just want to discuss a very good concept here. Let us talk about sodium. Sodium it is going to have neon 3s1. So when you talk about sodium, one electron is removed by IP1, you are going to get sodium plus. And this sodium plus electron configuration neon का बराबर होता है. So if you want to remove one more electron, it is going to become sodium 2 plus. So removal of, we know IP1 and IP2. IP2 is large greater than IP1. But here you are removing electron from neon configuration. इसका वजह से क्या होगा? It is going to be super greater than IP2. Mind it. Yes, Shasha, right? So this trend, there is a huge difference in the values of this IP1 and IP2 is attributed to any element present in the group 1. Mind it. Any element in the group 1. Mind it. Leo, fanboy. So at least Leo, fanboy, you just simply say hi to the class or simply say hi to the teacher first. Okay. Okay, Hemant. Now let us take one more example over here, magnesium. Magnesium is going to have neon 2s2. अगर मैग्नीशियम से एक इलेक्ट्रॉन निकाल के मैग्नीशियम प्लस बन गया IP1 होगा. So you can remove one more electron IP2 करना, so that it is going to get magnesium 2 plus. मैग्नीशियम 2 प्लस का इलेक्ट्रॉन कॉन्फ़िगरेशन नियॉन का बराबर होता है. अगर IP3 इस्तेमाल करना चाहते हो मैग्नीशियम 3 प्लस बनने के, सो IP1, we know that IP1 and IP2 and IP3, बच्चों, we know that IP1 is less than IP2, IP2 is less than IP3. It is going like this, the same trend. Yeah, but here IP3 large greater than this क्योंकि ये नियॉन इलेक्ट्रॉन कॉन्फ़िगरेशन से इलेक्ट्रॉन निकालना मुश्किल है ना बेटा? अशोक यादव. Now, so this trend is observed any element of the group 2. Mind it. So let us come back to our question. I want to say IP1 and IP2 and IP3 and IP4 and IP5, how many IPs it can have? जितना इलेक्ट्रॉन होता है उतना IPs you can have. बहुत आ रहा है अल्तमेश, कोई प्रॉब्लम नहीं. ऐड बहुत आ रहे हैं आज लाइव में. ओके, कोई प्रॉब्लम नहीं, यू स्किप ऐड, राइट? Now, if you see a huge gap between IP1 and IP2, it is supposed to be group 1. It is supposed to be group 2. See the logic, see the logic. So, आज हमारा क्लास में ज़्यादा ट्रिक्स भी बताना चाहता हूँ. IP4, IP3 का बीच में कुछ गैप आ रहा है ना, ये ग्रुप 13 होगा पीरियोडिक टेबल में. यहाँ पर ग्रुप 14 होगा, ग्रुप 15 होगा, ऐसे. दैट्स अ डिफरेंट मैटर. नाउ यू कैन सी द गैप. ओके, देयर इज ओके इंक्रीज्ड. अरे देयर इज अ लार्ज जंप, देयर इज अ ह्यूज जंप. बढ़िया, खतरनाक है. सो देयर इज अ ह्यूज जंप. सो IP1, IP2, IP3 एंड IP4 से IP5 तक ज़्यादा जंप निकल रहे हैं. ओके, सो द IP4 से IP5 इट इज सपोज टू बी ग्रुप 14, है ना? सो उसमें कौन सा ग्रुप 14 आ रहे हैं? दिस इज ग्रुप 14. सिलिकॉन इज ग्रुप 14. आंसर इज गोइंग टू बी B. You love this trick, everybody? Everybody love this trick? Clear, beta? You all take the snapshot of this trick. Identification of element. Thank you very much, Maunika. Your appreciation, your positive comments helps us a lot and boost our energy a lot. Thank you. God bless you. Right? Now, slide, promotional slide here. NEET 2025 All India Test Series Pack. And अल्तमेश ये टेस्ट सीरीज में 27 AITS एग्जामिनेशन होगा, 13 यूनिट टेस्ट, 4 पार्ट टेस्ट एंड 10 ग्रांड टेस्ट बेस्ड ऑन नीट पैटर्न. एंड उसमें 20 ऑनलाइन नीट फुल सिलेबस मॉक टेस्ट भी मिलेगा एंड 25 नीट टॉपिक वाइज एंड 3 PCB बुक्स अलॉन्ग विथ वीडियो सॉल्यूशंस एंड डिटेल सॉल्यूशंस एंड परफॉर्मेंस रिपोर्ट्स अलॉन्ग विथ श्री चैतन्य स्टूडेंट्स. सो मैं क्या बोलना चाहता हूँ आपको, अगर आप कुछ एग्जामिनेशन को, कोई भी एग्जामिनेशन मान लो नीट एग्जामिनेशन हमारा, so any examination you are preparing, you should know where you stand and how you are preparing. For that you need a proper assessment. Yeah, ये assessment के लिए Infinity Lane is designed a scientifically designed test series pack and these many facilities in India nobody is giving, only Infinity Lane is giving. इसका 5,999 था. अगर आप YouTube 50 ऑफ कूपन कोड आप एंटर कर सकते हैं ना, ऑटोमेटिकली आपको डिस्काउंट मिलेगा 2,999 तक है. सो डिस्क्रिप्शन बॉक्स में लिंक है, एक बार लिंक क्लिक करके आप कर सकते हैं. ओके, सो माइन इज डन. ऑल द बेस्ट फॉर योर नीट एग्जामिनेशन विद दिस टेस्ट सीरीज. ओके, चलो बेटा आगे और क्वेश्चन आने वाले हैं. टेक इट. And in which case the energy is released is minimum. Now Yashasya Sharma, I am coming to your point. So energy is released is minimum. So why energy is released? What is that energy you call? That's your doubt, Ashashwa. That is called electron affinity. है ना? So electron affinity, almost 35 minutes ago you asked this doubt, still in the live class. I just on your name I am discussing this. But so please honor these classes and attend the classes on the regular basis. सिर्फ आपके लिए. Now you can see an element जो है ना in the gaseous state, अगर एक electron add करने तो so a element इसका stability डिस्टर्ब करके x माइनस बनेगा. सो इलेक्ट्रॉन heat is released and that heat is called as electron affinity. है ना बेटा? So the electron affinity for this chlorine, phosphorus, nitrogen and carbon. So the one which has high electron affinity will have high heat, low electron affinity will have low heat. In that nitrogen he is having the lowest energy that is released. Of course sometimes it is going to be endothermic, some books it is given is endothermic. Minimum would be who would easily gain the electron. Now the who will easily gain the electron will release more energy. ठीक है, हाईएस्ट इलेक्ट्रॉन एफिनिटी. ओके, ये प्रोसेस करने का वक्त में एनर्जी रिलीज कर रहे हैं ना. सो किसका जल्दी लेना चाहता हूं उसको ज्यादा एनर्जी देते हैं बाहर. यशस्वी शर्मा, राइट? यस, ऑफ कोर्स, इनवर्स. नाउ टॉकिंग अबाउट द इलेक्ट्रॉन एफिनिटी वैल्यूज फॉर द हैलोजन शोन इन द फॉलोइंग. सो आपका आता है एक्सेप्शन का है फ्लोरीन, chlorine, bromine and iodine. So electron affinity decreases down the group, है ना. लेकिन fluorine, because of this small size, it is going to be exceptionally small. Okay, so that you can check the answer. Maunika, I am explaining you now. Now the change answer. So fluorine, chlorine, bromine and iodine. Okay, and it is cheating. Options are shown, you see, cheating. Ulta fulta de rahe. So the answer for this question is going to be, according to Maunika, yeah, it is A. Everybody is here, NEET 2025 NEET के एस्पिरेंट्स है. ठीक है बेटा, क्लियर. नेक्स्ट और एक है, द प्रोसेस रिक्वायरिंग एब्जॉर्प्शन ऑफ एनर्जी. द प्रोसेस रिक्वायर्स एब्जॉर्प्शन ऑफ एनर्जी. Now you just see, if an element takes an electron, x minus takes an electron, x2 minus takes an electron, x3 minus, and it goes like this. The first one, energy is released when isolated gaseous neutral atom is taken, so it is going to be exo. First electron affinity is going to be exothermic all the way. Exothermic all the way. While you want to add one more electron, incoming electron को repulsion करना है. So that you have to push the electron with a lot of energy. So it is going to be endothermic. It is going to be endothermic. You are going to be endothermic. ओनली फर्स्ट इलेक्ट्रॉन एफिनिटी खाली एक्सोथर्मिक होगा, बाकी जो इलेक्ट्रॉन एफिनिटी E2 and it is going to be E3, it is going to be E4, जो भी है always are endothermic process होगा. Altmesh, it is going to be F minus exo, endo. My answer is C. Yashashya, you said D, it is C. है ना बेटा? Hope you like the questions that we are discussing in the class. है ना? Right? Do you feel these questions are definitely helping to you increase your knowledge as well as practicing abilities? So I am personally making this content. So the best of the best I just want to give the students. Everybody in the chat box, give your response. Thank you very much, Yashashya Sharma. Thank you very much. Learning students in this session, students are learning concepts with Suresh Sir from Infinity Lens Studio. So even that glimpse gives a positive support, and yeah, thank you very much. Thank you very much. Right? Now, just a minute. Yeah, you got it. Now, one more question. Thank you very much. The XX bond length is 1 angstrom unit. CC bond length is 1.54. If electronegativity of X and C is 3.0 and 2.0 respectively, then CX bond is going to be. Very good to see. हमारे स्टूडियो में मैं इतना मेहनत कर रहे हैं ना सिर्फ आपके लिए, आपसे मैं कुछ नहीं मांग रहा हूँ, है ना. Simply by looking at that comments from the students, that boost a lot. Okay, thank you very much for your all positive comments. Really? Okay, now I just want to say here it is very important. Okay, when the electron negativity difference is very less, okay, it is 1.0, the value is going to be इसके average में मिलेगा. ठीक है बेटा. Now we'll discuss about Aldred Riccio everything. Okay. Now correct, in tomorrow's class I'll come up with various scales of electronegativities. Come on. So correct order of electronegativity of NPCSI is Sai Krishna. NPCSI. Nitrogen, phosphorus, carbon, silicon. So nitrogen is more electronegative than. You want me to show the electronegativity values as well. Now it is nitrogen is more electronegative than carbon, than phosphorus and silicon. I have the table as well. I have the table as well, right? I am going to show you the table, right? Now the Mulliken scale of the electronegativity uses the concept of electron affinity and electronegativity of Pauling, electron affinity of atomic size, electron affinity and ionization energy. So according to Mulliken scale, electron affinity and ionization potential average is going to be the Mulliken scale electronegativity, right? So my answer for this question is going to be C. Okay. So I just want to close this by discussing the electron negativity. Here I just want to Mulliken electronegativity scale. According to Mulliken, the electronegativity of an element is the average value of the ionization potential and the electron affinity beta. So that electronegativity is going to be electron affinity and ionization potential by 2. Whenever you just take these electron affinity values in the electron volt unit. Okay, that's very important. Now, another scale, Mulliken scale after the Pauling scale. Mulliken scale after this is the Pauling scale. Pauling scale is related to resonance energy, that is delta AB of a molecule, because this is based on bond energy of a molecule AB with an electronegativities of atom is A and B. If XA is the electronegativity of element A, XB are the electronegativities of element B, then difference between the electron affinity or electron negativity of A and B is given as 0.208 root delta is equal to XA minus XB, electronegativity of an electronegativity of B, and the difference is going to be the 0.208 root delta if electronegativity of A is greater than electronegativity of B. So it is also given in the different experimental and theoretical values how the resonance energy is calculated, it is given here. So this slide can help you to understand some questions based on high level questions, and in next class we are going to discuss about the how to use this scale and how this is given. And today we completed almost 40 questions, right? Hope you like these questions. And we covered atomic size, electron affinity, electronegativity, ionization potential, metallic nature, sizes, electron configuration, and tomorrow I'll come up with some other exceptional cases as well. So Altamesh is coming, Maunika is coming every day, Suresh Kumar is coming, okay, everybody is coming in regular basis. I really appreciate, and today we are done with the session, and tomorrow in the same time I am going to discuss some more questions, some more assorted questions for your NEET seat guarantee program. Okay, thank you very much. Signing off, Suresh from Infinity Lens Studio. God bless you all. Bye bye.